All right, so we already know how to calculate the sequence given a rule. Now we're going to calculate the rule or determine the rule given a sequence. So in this lesson, we're going to look at here we're supposed to get the rule given a sequence. Rule given a sequence, and then the objective. The objective is as follows. You're required to derive an appropriate rule given the terms of a sequence. All right. So first off, let's talk about determining the rule. All right. Determine the rule. All right. So first thing you would realize is that there is not one type of rule for a sequence. There are many different types of rules. So what we're going to have to do is we're going to have to approach this systematically so that we can rule out the most common ones and then move our way on to the least common ones. So there is not one type of rule for a sequence. I should put that full stop. There are many, so we will use a systematic approach to determine the rule of the sequence from most common to least common. All right, let me just make sure that this is a capitalization here. All right, so we're going to go from the most common to the least common. So that means we're going to look at the most common methods that you go about using. All right, so the first one that you would use is to observe the terms of the sequence. All right, now what do I mean by observe the terms? Some sequences that you encounter are going to be very simple. For example, the set of natural numbers, set of prime numbers. Well, that's not a sequence. Set of odd numbers, set of even numbers, set of multiples of 2, things like that. So you can simply observe the sequence and it will be that one of the known sequences that you're very familiar with, like your multiples of 3, multiples of 5, multiples of 6, and so on and so on. Those that we defined earlier in a previous lecture, those are the ones that make up the sequence, and those are the easiest to find. All right. The second one that we will do is, let me just put a tab here as well, so that this can be right. Oops. All right, good. Next one is to check for common differences between each pair of consecutive terms. If the differences are the same, it is an arithmetic sequence, and so the rule is that rule, I'll just write that in orange. Right, that rule will be an is equal to a1 plus n minus 1 d. All right, so this here is for you to determine the terms of a sequence. All right, let's say for instance this, well, let's define each of the terms here. So this here would be the first term. All right, this here would be the common difference. I should probably put a different color, honestly. Let's use a white. Common difference. This here, n represents the natural number in position. So let's say we're looking at the fourth term, that n will be 4. If you're looking at the fifth term, that n will be 5. And well, obviously it's the same n over here. All right, so this is the term, the nth term. So a1, which is the first term, plus n minus 1, which is the position in the natural numbers minus 1, then multiplied by the common difference. So let's say, for instance, we have something like the second term, right? Let's say a2 is what we want to calculate. Then let's say a1 is 2, all right? A1 is 2. Let's say the first number in the sequence is 2. Let's say we're looking for the second term in the sequence. Then it's 2 plus open bracket 2 minus 1, and then let's say the common difference between each one is 2 as well. So we'll see that 2 here plus 2 is 4. Let's say we're looking at the third term. So a3 will be 2 plus 2 plus 3 minus 1 into 2. So we can see that is 2 plus 2 into 2, which is 4, then we get 6. Notice that we are going, if a1 is 2, and then 4, and then 6, notice that we're going in 2s. We're looking at the set of even numbers. All right? So this is one of the ways. So this is a common difference way of identifying the sequence. The next one that we have, which is the third one that we have is to check for common ratios. If the ratios are the same, the sequence is geometric, then the rule is, and that rule will be again in orange, an will be equal to the first term times that common ratio raised to the power of n minus 1. So a1 is the same thing, first term. R is the new term that you don't know yet, so which I'm going to define here for you. This is the common ratio, not ration, ratio. So that is the common ratio. N is the number in the set of natural numbers. So the first term, second term, wherever. All right. If it is that it's of this terms, let's say we start with 2 again. All right. So let's say a1 is equal to 2. Then a2 would be equal to a1, which is 2, raised to the power of, let's say that we're looking at 3. R is 3. Let's say the common ratio is 3. All right, let's say the common ratio is 3. And then n is 2, so n minus 1, 2 minus 1. And we'll have 2 into 3 to the power of 1, which is 6. Let's say a3 would be 2 into 3 raised to the power of 3 minus 1, which is simply 2 into 3 to the second power. 3 to 3 is 9, plus 9 by 2 is 18. And so far we're seeing that the sequence goes like this: 2, 6, 18, and so on. All right? So what is a common ratio? The common ratio is just simply this number here divided by the previous number. So in this case, it would be 6 divided by 2, which is 3. And in the other case, let me just go through the next one time. Here, 18 divided by 6, which is 3. So if we take consecutive terms and we divide them, we're supposed to get the same value, which is the common ratio. So if I take 6 and I divide by 2, I'm going to get 3. If I take 18 and divide by 6, I will get 3. And that means there's a common ratio in between them, which is 3. All right, let's go on to the fourth one now. So the fourth one is to check for quadratics. Sequence. All right, so we're supposed to calculate the first difference between consecutive terms if the first difference are are not constant, if the first difference are not constant, then calculate the second difference between consecutive terms if the second differences are constant. If the second differences are constant, then the sequence is quadratic. The sequence is quadratic. All right. So let's say, for example, let me just put a new line here. Let's say, for example, I'm going to put my example in purple actually. Right. All right. Let's just agree. So let's say, for example, that I have a sequence of, let's use squares, right? 1, 4, 9, 16, 25. I know that those are square numbers. Let's look at the first difference. First difference. If the first difference is 4 minus 1, which is 3, 9 minus 4, which is 5, 16 minus 9, which is 7, 25 minus 16, which is 9. All right, so we can see right away the first difference is, let me just highlight it more. So this is 3, 5, 7, 9. And then let's look at the second difference. Let's look at the second difference. And we can see that if we take 5 and we minus 3, we'll get 2. And if we take 7 minus 5, we'll get 2. And if we take 9 minus 7, we get 2 as well. So we can see that we're getting a constant here. So this is 2, this is 2, this is 2. So we identify right away that we're getting a constant. So in this case, the rule, let me just put that there, the rule would be of the form each term is equal to a n second power plus b n plus c. So we can see right away it's going to be n squared. So the rule for the sequence is n squared. All right, so it's n squared. We can see that if I take the first term, which is 1, and I square it, I get 1. I don't need to multiply anything, and this is 0, and this is 0. So b and the c term is 0. All right, if the first term is, in this case, let's see, 1. I'll just put that in yellow actually so you can see it. So if I say that the first term here is 1, so 1 by 1 is going to give me 1. 1 by 1 is going to give me 1. So I can see right away that is a n to the second power should give me 1. This here cannot add to anything, so this has to be 0. This here has to be 0 as well. So there is no c, there is no b, there is only an a, and that a is 1. So from now on, all I have to do is check the rest of this. So a is 1, then we have n, which is going to be 2 by 2, which is 4. We see we get that. Then 3 by 3, we see we get that. And you can notice right away that n is a member of the set of natural numbers, and we're just simply counting as we go along, right? So 1, 1, what can I substitute for a, b, and c so that I'll be able to get a n as 1? So I can substitute a as 1, I can substitute b as 0, and then 1 to the second power is 1 by 1 is just going to give me 1. Then I look at the next one, 2, 2. I can see that for me to get 2 squared of 4, I would say 2 squared by 1 will give me 4. But then the b here needs to be 0 still, so that I will be able to not add anything to that 4. And you can notice right away how you determine the rule as just being n squared. All right, the last one that we're gonna have to do is to compare. So let me just put this here, number 5. So the last thing that we have to do is we have to compare the sequence QUENC sequence with known sequences. right? So this is like, hold on, like triangular numbers, etc. Right? So these are the uncommon rules, right? Like your pentagonal numbers, your quaternary numbers, your triangular numbers, things such as that. Those sequences are not very often used, but you can remember them so that you'd be able to identify them quickly. So for example, in this case, we're going to look at triangular numbers, right? And triangular numbers, let me just put this here in orange. So let's say, for example, I have the numbers 1, 3, 6, 10, and 15. Those are triangular numbers. And triangular numbers are determined by the rule of an equal to n into n plus 1 all over 2. Right? So, as I stated before, the algorithm that I showed you is going from the most common sequences that you'll encounter during your math course all the way down to the least common that you will encounter. And if you practice as many problems as you can, identifying the rule of a sequence, you'd be able to do this with great ease as you get more practice. All right? Oh, this here is supposed to be green. Okay, so good luck, and I will see you in the next lesson.